We discussing about Snowflake and DBT. So interview regarding interview. So when you know SQL, Snowflake, AWS S3 services, and DBT. So it is ELT tool. Okay? Extract, load, transfer. So what is a project? What we have? So it is like a so we have data migration projects. Data migration projects like healthcare, domain, or bank, retail, okay, different projects we have. Suppose if you have like healthcare, so we have multiple hospitals, multiple cities, right? And overall worldwide. So we need to handle those data like patient details, okay, and incident details, doctor and medicine prescription, and so we need to hide some sensitive data, okay. So what is our cost and everything. So we have when we go in real time, we have multiple tables, not 10 or 20, 150, 200 tables we have in real time. So those data. So it's like a migration project, like we are migrating data from Oracle to Snowflake, or maybe different source systems like SQL Server, ERP system. So different SQL servers we have. So directly we can't load data. Okay, it means we can load, but we don't do directly. We don't do that process. So I can do Snowflake. So in between, there will be ETL team. So what they will do? So using Informatica, so Power Center like that, they will push data into AWS S3. Okay, AWS S3 bucket. So not only S3, we have Azure World Storage and the GCP. Okay, so as a cloud provider, we are discussing on the AWS, right? So they will push data into AWS 3 bucket. So after that, as a Snowflake developer, our process will be start. So what we need to do, as per the requirement, we need to create the integration, storage integration. So with our ARN, Amazon resource number, and S3 URL. So that bucket. Okay, so we need to create a storage integration. After that, we need to discuss the integration. Then we will get new user ARN. Then we need to update the policy. Okay. So after updating, the connection is established between Snowflake and AWS. Okay. So there after we need to create the stage is storage integration. So thereafter we need to do the storage integration with ARN and S3 URL. After describe it, then new user error will get update policy. You need to explain everything step by step in interview. Update policy, then connection established between Snowflake and S3. Then after we need to create a stage. So this is like with S3 URL. So where we have data from that link S3 URL. So same thing we will provide in this integration also. So then integration name. So here we need to mention. So after that we need to check the data. So what is the file format, everything. So after that we need to create the file format. Then after copy command target table. Then copy command. Okay. So copy command if data is bulk, copy command. Okay, and if data is continuous or live data, Snowpipe. So we need to again same thing. I mean like same process as Snowpipe also. So we will attach Snowpipe with copy command. After creating pipe, we need to describe the pipe. Then we will get some notification. So we need to copy that one again. We need to go to S3 bucket. So from where we are loading data. So there we need to create some event notification. Then so whenever the data is loaded into S3 bucket, automatically the data going to load into the target table. So they will ask, okay, instead of creating pipe, you can create task, right? So why we don't use task? Task is for only specific time. So 1 hour, 2 hours. like that. But Snowpipe, when the file load into the S3 bucket, automatically it's going to trigger Snowpipe. So it's going to load data into the Snowflake. Okay, this is the process. Okay, so sometimes S3 is a raw layer. So here we're going to load, okay, staging like that. Okay, so first we will load data into the raw layer. Okay, so after loading data into the raw layer, so what we do next, we will put data, we will clean the data as the requirement. After loading the data, we need to delete the duplicate values. Okay, remove the null values. Okay, so we need to change the column names. Okay, so usually we going to receive denormalization tables. After that, so we're going to do the normalization. Okay, so like that, different, okay, unnecessary data, unnecessary spaces, we need to use trim SQL, and duplicate values, row number, window functions. Okay, we need to apply some transformation, we need to clean the data, then we need to move the data, we need to put in the staging. Okay, so this one how you going to put directly staging. Okay, you have both in Snowflake, we can do the transformation. So as of now project, we are using DBT, right? We need to connect with the DBT, then we need to do the transformation automatically. So the transformation tables are these, it going to uh, be in the staging layer. So in that we need to mention whether tag, we need to use tags. So we need to mention the schema. Okay, so those data are going to replicate in this staging layer. So after staging, next is curated layer. Curated. Okay, this is a basic thing. In curated, what we have fact and dimensional tables. So ready data, completely normalization data. So those data we're going to share with the reporting tools. Okay, this is a raw layer, stage, and a curated layer. Okay, so you need to explain our project. Okay, this flow project has been nothing but this flow. Okay, so loading data, then removing duplicates, then we are moving cleaning data raw layer to staging. So then after factor damage to the curator layer. So this is standard names. These are standard names: raw layer, staging, and curator layer. But in real time, so maybe having like presentation layer, transformation layer, final layer, reporting layer. Okay, so they will have different names. Okay, so just follow this one. Okay, follow this one. So instead of curator layer, you can tell a presentation layer. Okay, so these are, so what are the environments we have? Dev, test, then prod. So these are how you going to move data. So in Snowflake with GitHub connection setup, we going to move dev to test to prod. Okay. So when you connect with the DBT with CI/CD continuous integration, continuous deployment. So with that you can move data dev to test to prod. These are the environment. Okay, environments in the Snowflake dev test prod. So what are the layers in DBT? Staging, intermediate, and marked layer. Okay, staging, intermediate, marked layer. Staging, intermediate, marked layers in the DB. We have that layers. Okay, so this is the dev to test to prod. These are the involved in the Snowflake. Okay, so basically, okay, what are the tests you have done? Like a unique test, null test, accepted values test. Where we going to do in DBT. So in DBT we're going to do. Okay, why DBT? Still we can do the transformation Snowflake, right? So DBT means we can do transformation Snowflake, but in DBT we have like modality reusability. But we also have store procedures in the Snowflake. We also have reusability and modality in the Snowflake, right? So why then DBT? So DBT is nothing but we also have lineage graph and documentation. So we can easily schedule the job schedules using the DBT cloud scheduler. Okay, so we can have macros, reusable codes, macros, ginger templates. Okay, the best thing is go with lineage graph documentation, CACD pipeline. Okay, we can move data. So we can do more and more in the DBT. Okay, like that. So they will ask you. So project is nothing but I have provided that. Not bad, go with that. Okay, so don't try to copy that work same as it. Okay, so read it what you understanding, just write in your own words, then prepare for that, then yeah, you will you don't forget again. Okay, so then easy to you explain the interview. So suppose if you don't write on your own, if you follow want to same as in what I given, So then in that scenario, you need to buy her those things, right? So don't do, okay, read it what I given. So for that you make on your own some notes that will be useful to you. So even self induction, okay, scrum call, okay, project vision and roles and responsibility. Roles and responsibility, nothing but simply what you have explained like in project explanation. Okay, so what you have done, same, I'm creating storage integration, I'm using Snowpipe. So handle increment, I created streams, okay, for incremental data. Then for historical data I applied HTTP type 2 storage change in dimensions. So type 0, 1, 2, 3, 4, 5. Okay, so we have, right, storytelling dimension. So tell us, so most of the time we're going to use only AC type 2. Sometimes AC type 1. So go with AC type 2. Okay, so to access the historical data, we use AC type 2. To incremental data, we're going to use streams, merge statement, task. Here, okay, this one. They will ask those roles and responsibilities. So in DBT, what you have worked on models, okay, test snapshots incremental. That is enough. So don't go with more. Okay, in DBT models test snapshots incremental model. Okay, go with other things, like macro, jinja, hooks. Okay, that contest, but because I didn't get chance to work with them, but if I get chance, I will work. So tell like that. But if you find it anything in responsibilities in job description, then you need to tell yes, I have worked. If you are not fine, just tell I have not. First go with job description, what they are telling in that. So you need to tell, you need to have, okay. And also don't put resume with Python and Spark in other things, Airflow, okay, ADF, other things. Just put only SQL, okay, Snowflake S3 services DBT. Okay, if you put the wasting of time, okay, so hours we are wasting our time and their time, so there is no use. So just try to attend only 1 or 2 interviews. Don't try to attend 10 interviews. Okay, that is enough. 1 or 2 interviews are enough to clear interview, but we need to do the proper preparation. Don't hurry. I have scheduled interview, do it, don't hurry. Just proper way, follow, practice, clear in 1 or 2 interviews. That is enough. Okay, so this is environments, Dave test proud rally staging dedicated how you move data in a stove like GitHub or in DBT CI/CD continuous integration cut to deployment. Okay, there we need to move there. So we have zero copy cloning, right? So they will ask about zero copy cloning. Okay, so how we going to, where we use, so for quick backup data we're going to use, why we don't use, we can copy dev to test to pro, right, data. What will happen if you copy like that in real time? So in dev I have table, I'm copying to test, then I come to pro. What will happen, so you have some data, you are using zero copy cloning and you're copying into test environment, after you're copying it test to pro. But you have here 100 records in test, 100 records pro 100. But sometime in dev, some data you're going to receive, right, some more 100 records, but you don't, this test one don't have those records, right. And even in pro also you don't have the those 200 records, only we can see in dev development. Again you're going to do the copy. So not like, that's why we're going with GitHub or in CI/CD pipeline. It's going to update. Okay. So when we move the data, it's going to reflect it. Even what we have in dev 200 records. So in test also we have 200 and the prod also we have 200. So we need to maintain the data consistency. What is the data consistency means? So from source what we are receiving, we need to maintain up to the further target. Like when we are sharing data with a client, okay, we need to maintain everything. So in source, we provided 100 records. In target, when we're sharing the client, we need to have give 100 records. Okay, so we need to maintain every data, right? Okay, and it's securely. That is data consistency. So okay, so zero copy cloning table, clone table, clone table. Okay, so this one. So what you're going to do? So after cloning, both tables are independent. So this clone table don't have storage and no storage cost. only having the compute cost. Okay, so if you do any DML operations in the table, uh, base table or in clone table, it won't reflect in the clone table. So after cloning both, after cloning this table, base table having 100 records, 100 records. I'm cloning, then it will also have the 100 records. So after cloning, I'm inserting some more 10 records, but this base table have 110 records, but still clone table have only 100 records only.
100.
100 records only. Okay, it won't. But okay, after cloning, both tables are independent. Okay, so where it going to fetch data? So when we fetch the query clone table, it going to be have micro partitions, right? So clone table, so that, okay, we're going to store in the cloud services layer. So then if you drop the base table, still we have data in clone table, but if you drop the, still how can we call, still we have the micro partition until its time travel period. Okay, but after, what is the base table time travel period, how can it going to fetch data? So still we have data in cloud service array in the format of metadata. From that it's going to fetch the data. Okay, so this clone table don't have the storage, no storage cost, only the compute cost. Okay, if you do any DML insert delete update, then clone table going to have the compute cost. Okay, then base table having the micro partitions and clone table. If I insert new data in clone table, it's not going to disturb this original micro partitions. So this clone table going to create new partition when we insert new data into the clone table. But when we insert new data into the base table, it's going to rearrange the micro partitions by default. Okay, by default Snowflake going to take care of the partitions. Okay, so we don't have indexes in the Snowflake. So indexes, instead of indexes we have cluster key, okay, and micro partitions. Okay, instead of indexes we have micro partitions and cluster key. Okay, so cloning concept is clear, right? Good. So we don't have the indexes in the Snowflake. We have instead of micro partitions and a cluster key. So this is how the data will be stored in the Snowflake. Okay, indexes won't work in the Snowflake. Remember this fact, they will ask in the interview. So the data going to store in the micro partition in the columnar format. So each field going to store like 50 to 100 MB. Okay, in the farewell. So the microbiome will store data like where is the maximum value, where is the minimum value. When we query, it knows, Snowflake knows where is the maximum minimum value and what is the row count and what is the metadata. Everything is going to store the format of micropartition in each field 50 to 100 MB. This is columnar format. Okay, so rows going to store in the columnar format. Okay, and cluster key. So cluster key is nothing but for the performance tuning. Suppose I have large table, so I'm using employee ID many times in the SQL query. So in that scenario, I will apply cluster key and the employee ID. So it's going to fetch the data very quick. Suppose I have 1 crore records. So it's going to, when I apply cluster key and the employee ID, it's going to fetch the data very quick. So that is a cluster key. So what is the rules? The table should be large and that column should be used repeatedly in that query. So in that scenario, we're going to apply the cluster key. Okay, so what is the limit to apply cluster key? So there is no limit. We can apply in all columns. But if you apply in all columns, there is no use. The real time we're going to apply only maximum 3 columns only. 1, 2, 3. Okay, any 3 columns only, not on the columns. So example like date, region, or salary, employee, anything, only 3 columns. Suppose if you apply more than 3 columns, there is no use. Okay, and it going to cost effect. Okay, so that is cluster. Instead of indexes, we have micro partition and cluster key in the Snowflake. Okay, so then time travel, what is the time travel? Okay, so if any data is updated wrongly or any data is deleted, any disaster happened, so we can add the historical data. So by default, it will be time travel will be only 1 day. So we need to use the alter data retention time in days. So up to 90 days we can give. So we can't give more than 90 days. So up to 90 days you can give. That is the time travel period. Okay, so after 90 days, still if you want to retrieve the data, there is one option. So that is fail safe. Okay, so you can't access directly fail safe, and there is admin or anyone who have the but admin roles who have admin roles, they need to go to support.com, snowflake support.com. So then they will be uh, some like Snowflake team customers. So they will inform to the Snowflake engineers. So who are the Snowflake engineers? They are working in the Snowflake company. Okay, not in our company, Snowflake company, those we need to call them, those are Snowflake engineers. Then they will uh, discuss what is the data, how much 1 TB 2B, and the depends on the data, and they will check it. Okay, they will check it, and it may be 1 hour 2 or 3 hours. Okay, they will give you back. But suppose or bad luck, sometimes it will take more than 3 hours, it's going to 1 or 2 days, 3 4 depends. So they will record for us separator, they're going to create some database schema, then they will provide the step that is fail safe for 7 days. Totally we can data protection cycle is up to 90 days plus 7 days, 97 days. So this is by default only 1 day. So we have permanent tables, okay, temp tables, transit tables. So permanent table having by default 1 day time travel period, and temporary table also 1 day, and transit table also 1 day. So we can give using data retention time, so up to 90 days. Okay, so 7 days fails. Okay, 7 days fails. Okay, and the temporary table only having the only 1 day time table time travel, no fail safe. So transcendental only 1 day time travel, no fail safe. Okay, no fail safe for this. Only 1 day time travel by default we have. So okay, this is, and here zero copy column we are using for backupping and quick data copy without a duplication data. Okay, remember that point. So introduce without duplicating data, we are copying the data or we are cloning the data. Cloning or zero copy cloning are same. Okay, so yeah, see, I'll tell you what are the temporary tables. So these are session based tables. So we have worksheet, right? So we can click on plus button, we're going to see SQL file, again one more plus, some more SQL file. Okay, those are session based. If you want to see any data or any when you receive data from, so if you want to check the data, so what are the, how many columns are there, if you want to do anything that is not important to store in the database in Snowflake storage, there is no important. In that scenario, you're going to create a temporary table session based. If you close that worksheet, that SQL file, okay, worksheet, it's going to delete from the database. Or if you uh, sign up in the account, it's going to delete from the index database. So once if you close the sign out, or once if you close that one, you can't recover it again using 1 day time travel period also. But if still if it is active that worksheet, then if anything deleted, you can retrieve using time travel to only 1 day. Okay, so transient tables. So these are in real time. So most of the time, if there is any important, we're going to create a permanent table. If there is not important, okay, there is no need to give time travel period up to 90 days or 60 or 30 days. So in that scenario, we go with transient tables to save the cost and everything. So most of the time, we're going to create only transient tables in the real time. So not every time permanent table. Okay. So not every time permanent table. We're going to create the transient table to save the cost, and it is a staging. Okay, transformations. We go with always transient tables. Okay, it's going to be key. Okay, but there is no only 1 day time travel period. Okay, so temporary table, transitive, permanent table. Okay, so there are how many ways to retrieve the data? We have three methods. So offset, query ID, timestamp. Okay, that I will explain. I will give the code. Okay, no worries. And using it and before, it before. So those are there. Okay, using it before, offset, query ID, timestamp. Three ways are there. Okay, so 90 days. Okay, this is it. Okay, what is the Snowflake architecture? We have layers, right, in Snowflake. Okay, so what are the layers we have in the Snowflake? Previous one is what is its architecture? It is multi-cluster architecture. Multi-cluster. It means we can use. So I will explain. Okay, so we have three layers. I will explain about multi-cluster. Go with layers. So three layers: storage layer, and so compute layer, or we can call uh, compute layer or query process layer. So okay, there is different query process. Okay. Then cloud services layer. Okay. So Snowflake built on entire cloud. Okay. Snowflake built entire cloud only. Okay. So this cloud provider, what is the Snowflake cloud providers? AWS, ADF, sorry, AWS, Azure, cloud storage, and these are cloud providers to the Snowflake. Okay. Cloud services layer. Okay, sorry. Okay, we have AWS, Azure, and the GCP. These are cloud providers to the Snowflake. So that's one. Okay, so storage layer, so it's going to store the data. When we create table, we going to insert data. That's going to store in the storage layer. When we run the query select star from table, that's going to run in the query process layer. So it's going to store. If you want to log into Snowflake account, you need to have the username and password. Okay, they're going to store in this one. Okay, so in the storage layer, it's going to put the micro partitions format. Okay, uh, data and in cloud services like we have like virtual warehouse. What is virtual warehouse? Nothing but virtual is like a it is a computer set of multiple computers. It's having like CPU, memory, RAM, SSD. Okay, it's going to have the RAM, okay, SSD, CPU, and everything going to have like computer. So it is like engine. Okay, it's going to do the data loading, transformations, everything. Okay, you running any running query, the query going to run in this. We do transformation that going to do in this process. Okay, so cloud services nothing but complete security metadata, okay, optimization, everything in the cloud service. If you want to connect with the DBT, any other tool, you need to some security need, right? So that going to take care of the cloud services layer. Okay. Suppose if you run the query select star from table name where ID equal to one. So first it will check by the cloud services layer. Who is the running query? Which user, admin, user role, data entries, user running the query. It will check the query and it will check the partition. That partition it will provide to the compute layer. That compute layer, what it will do, it will what is the query and it will run it and the data comes from the storage. The query going to run like that. That internal process what I expect. So okay, so this will happen in the different real time. Okay, when run the query, you can see only on your screen, but behind it will happen. Okay, this process. Okay, you need to explain clearly. So in the okay, don't tension. Okay, go with slow, not very slow, slow. Don't to go with fast. Okay, don't tell. Okay, fast. Go with slow. So now this preparation I need to cover. So that's why I'm going a little bit fast. But in theory, you need to go with slow. Okay, so this one. So storage complete and cloud services layer. Okay, here we have. So so what is a multi-cluster warehouse? So suppose you have bike or car, right? Okay. So when you driving the bike, you're going to put first one gear, second gear, third gear, fourth gear, like that. It's going to pick up the speed when you go higher gear. So like that we have multi-cluster warehouse. It means suppose uh, you have one cluster, you are running one query, it's taking 10 minutes. So now you have 10 clusters, you are applying 10 clusters. Now it's going to run take only 1 minute. But when you using one cluster, it will be $1. When you are using 10 cluster, it's going to be $10. That's the requirement. Okay. So we have warehouse sizes like small, medium. Okay. Remember, small warehouse, medium warehouse, and large warehouse. So before small, we have X small. So after large, we have X large, 2x, 3x, 4x like that. We have warehouses. Okay. If you go higher warehouse, so it going to be higher charges. So the performance should be good. Okay, so when you go to increase the warehouse size, okay, so when the query is running slow in the Snowflake, in that time we going to increase warehouse size or you going to increase the clusters. So here difference we have cluster key and clusters are different. Clusters like gates, cluster key is like key is going to be the partition. Okay, so both are different. Okay, so we have like a scale up, vertical scaling, okay, and horizontal scaling. Okay. Okay, vertical scaling is like uh, scale up. Okay, and horizontal then we have scale down. Okay, scale up. What is scale up? Increase the warehouse size. Suppose small warehouse, okay, medium and large. Uh, higher large warehouse, medium, small like that. If we going to increase the warehouse size, scale up. Decrease the warehouse size, scale down, that is vertical scaling. And the horizontal scaling is scale out, scaling. Scale out means adding the clusters. Scaling is removing the cluster, not decreasing, removing. Okay. Scale out is adding the clusters. Scaling is removing the clusters. Okay. Remember this point. Okay. When we going to use? So when they ask about performance tuning, if the query is running slow, when data is loading slow, you need to go with vertical scaling or horizontal scaling. So you need to go with this one: scale up, scale up, scale up, scale, and use this. Okay. These words. Okay, like that. What you do for performance tuning? So you tell and where the select star, okay, check the James, Metless views, okay, CTE, okay, so you need to check the query, so like that, and bottlenecks, okay, so everything we need to check in the, okay, go check the, we need to check the query profile, so what are we taking, so with the specs, okay, like that we need to check, okay, this is vertical scaling, horizontal scaling, okay, so I explained about, okay, this one, right? So bulk data, copy command. Okay. Bulk data, copy command. Okay. Snowpipe. How we loaded data in Snowflake. So starting explain, right? Integration stage, file format, target table. So how we, okay. For incremental data, what we're going to use for incremental data. So streams concept we're going to use. Here we have made statement. Okay. Task for scheduling. What do you use task in Snowflake for scheduling? Task. Create task name, warehouse name. Okay, and then type it to mention the type. Okay. Then last statement, which is the copy command or like meta statement. So which SQL query you want to run, you will get attached with that. So it's going to run in specific time. What happens? 1 minute, 10 minutes, 1 hour. So like that. That is. So we are using task. Okay. With task, what we are using with task, you can use cron. Okay. We can mention cron also. Cron. CRON. Okay. CRO. Chrome also we are using. Okay. That we will mention in the time. Okay, so 1 minute like okay scheduling. So this is incremental process. Okay, they will ask different. So I will give the point. You need to go with this one. So streams concept we have incremental. Okay. So for the historical data, what we will use? How you access historical data is probably historical data. Historical data. Are you going to access historical data in Snowflake? Have you handled? Huh? Historical data. I have
Okay,
deleted
Kamal.
that data. What?
Time time travel.
Not a
Using
deleted
common
data,
command.
not historical. Not I'm not saying about a deleted historical. I'm telling about. So I have bank account. I want to see
SCD type.
transfer 1 year
SCD.
back.
SCD type 2.
Yeah,
You
see
give the
type
full.
2 we going to use. Okay, so they will ask dimensions. Okay, see type 2. Okay, slowly change your dimension type 2. So you know to explain. They will ask write it syntax. What are the columns that one? Okay. So one more thing in incremental in we have stream table, right? We're going to create stream. So in that stream table, what are the columns we have? Action, update, row ID. Okay. Yeah. What are the what are the metadata columns? Okay, they will ask in the interview. You know to go with remember action, insert, delete, update. So when you insert, what will happen? When you delete, what will happen? Okay, then update what will happen. That I explain the class. Okay, you can go with that one. Okay, insert, delete, update. False to you can find there. Okay, so those things and stream will capture the data. Okay, stream going to capture the data. So after running the statement, then stream table you don't have the data. It's going to move to the target table until the streams runs. Okay, so this is okay, incremental historical data. So then we have views rise and we have standard views. Okay, metless views, secure views. Okay, secure metless views and okay, and they used to call okay now non-metalized weaves and metallized weaves. Okay, they used to come. So weaves, standardly we don't have the storage. There is no storage cost. So every time it's going to run again and again. Okay. So metallized weaves have going to have the storage and storage cost. It will give the best performance. Okay, we're going to write an aggregate function like that. So secure. So suppose salary, some sensitive data is there, we go with secure. Okay, secure metallized, we're going to metallized the secure. Okay, so we're going to materialize V. We're going to give the high security. We're going to share with the data, right? That's why. So we're going to give to secure to the materialize gives when we are sharing with. So these are all weaves. So they will ask, can we write join condition on two tables with the metallized weave? Can we write metallized weaves on two tables? We can't write with the joining. Can we write metallized weaves? Two tables joining. So we can't write metallized weave on two tables with joining. We can write weave and secure weave, but we can't write metallized weave. Okay, remember this point. They will ask interview. Okay, so what are the limitations? So some window functions. Okay, these chains. We can't use metallized weave. Go with more. Okay, so and we also have the dynamic tables. So dynamic table nothing but okay. When directly we have data and source, so we want to see automatically transformations source to target directly. So in the scenario, we're going to create dynamic table and source table. So whenever the table receives data, it's going to update the data into the target tables. Okay, we're going to give some. We need to mention some time lag time. 5 minutes, 10 minutes, half an hour, 1 hour, depends on the requirement. Okay, so we need to. This is dynamic table, and we have isolate tables. Just I'm not working with iceberg tables. Okay, so we're going to go create these iceberg tables on the data lakehouse. Data lakehouse. We're going to create data external tables. Okay, external tables. Okay, just I worked with the dynamic tables, but I have not worked with iceberg tables. So I have not created. I have not get just because of this new features. Don't give it in depth. Okay, go with only dynamic tables. Iceberg tables not implemented. Just I know we going to create a data lake. S3 bucket is the data lake. Okay, so these are isolate. Okay, so what we going to do real time work? Okay, so we going to apply the business logic. What they given sales summary. Okay, so what is the price total summary? So what is profit? What is loss if loss? And what is profit? What is profit month wise, profit year wise? Okay, so what are the modifications we need to do for next product when we are new when we are releasing a new version like that? We need to scroll tables. Okay, these are and also go with story change over dimensions and those things. Okay, this then okay. So Jane now time is like 4:08. Okay, 4 p.m. 8. Now Jane okay 4:20. Jane 4:20 class. Okay. Now time is 4 and 8. After 12 minutes, Jane again in the class. Don't forget. Don't miss. 4:20 Jane in the class again. And so these are these are dynamic tables and iceberg tables. So I will open the syllabus. Okay. I will go topic. Okay. So this is Snowflake theory, like micro-partitions. Okay. That clustering key layers. Okay, so table types, time travel. Okay, so stages. So stages we have two types. Okay, one is like internal stages. Okay, so internal stages, there's are two types: internal stages and external stages. External stages. Okay, external stages. So what are these are? Okay, internal stages are like when we are loading data from on-prem the Snowflake, local machine Snowflake, we're going to use the internal stages. Okay, we're going to install SnowSQL. Okay, we need to log in with the username and account identifier with the command line, command prompt. Then we need to use database schema. Then we can load data local machine Snowflake. If the data is more than 250 MB, so there is direct option, load option. With that, we can load data up to 250 MB. But if the data is more than 250 MB, we need to go with the internal stage. User stage, table stage, name internal stage. Okay, user stage, table stage, name internal stage. So we have three stages, right? User stage and table stage. So how are you going to create these stages? So you no need to create these stages. By default, when you create table, automatically going to created by the only Snowflake in the Snowflake. Okay. Name it. So it's going to suppose I created name internal stage. I created one EMP table. Okay, EMP table I created. Then what is it? What is its user stage? So it is user stage is at the rate of tilde slash emp. It is the user stage name. So table stage. So at the rate of percentage. So it is the table stage name. By default, when we create the table, it's going to create user stage and table stage. What is the name internal stage? It is like stage, not table name. Directly we need to create stage name. It is a stage, so name. Okay, so why we use these three types? When we load data using user stage, it going to it only asks for like only one user, but it can load multiple tables. But when you use table stage, we can't load into the multiple tables, but it can accessible by the multiple users. Sit properly, Rajesh. Then name internal stage, both multiple users and multiple tables we can load the data. Okay, this is so external stage is nothing but AWS S3 and Azure Bulk Storage GCP. Okay, those are external stages. In integration, we created a stage. Those are external stages. Okay, so go with okay. Put and get command. We're going to use here. Put is we're putting the file local machine to the stage. Get is when we loading unloading data Snowflake to local machine. Okay, put and get command won't work in the Snowflake. It will work only in the Snowflake command line. Okay, if they ask. So this one. Then copy command, condition data, copy command options. Okay. So copy command answer what we can mention. So we can mention a lot like copy command. So simply copying to table name from stage name file format, that's okay. So suppose we have multiple files, okay, multiple files we have, okay, we need to use the files, okay, and pattern, okay. So if any null values, okay, we're going to do some transformations in the transformation with select statement, okay. I will select data from stage. We select data from stage, select $1, $2, $3 at the data stage name like that. You're going to select the so data from the stage. Okay. So in copy command, we can mention a lot. So I will show you this one. So stage this one first. Okay, force equal true, per equal true. So force equal true, what it is going to do? Once again, it will load the data, duplicate. So if already one file loaded into the data, the table. Same for if you load, you can't load again. Okay, you need to rename the table or you need to go with force equal to, then it will load again. So first, if you load without use force, if you try, it's going to check the copy history. So it shows metadata already it's loaded. Okay, then you don't load again. If it load again, it's going to be duplicate data. But we can use force equal to, we can load it again. Suppose if you use per equal true, what will happen? So it will load once. When you use per equal to, it will load once, and it's going to delete that file in the S3 bucket. Okay. Yeah. After loading data, it's going to delete in the S3 bucket. So that file you can't load again because of it's going to delete in the S3 bucket. Even we can't find that CS file in the S3 bucket. So that per equal to. Okay. So these we're going to use on analytical continue, or if any error in the data and validation more written all errors. Okay, so how are you going to handle error data? So we need to create the one error log table. So with the job ID, last job ID, we need to fetch those data. We need to insert in a error log table. Okay, so in the when you handle error log table, we need to create suppose customer data. So customer stage customers, customer target table, the customer error log table. You need to go to create more three tables. First, you will load data in stage that you don't have the proper data. You're going to have the some error data. So then after you need to fetch proper data, uh, and then you need to load into the customer target table. In error table, you need to use last job ID. You need those data, what you need, a file name or what is the error. So you can select and you can create table, customer error table. You need to load data. So statically we can handle the copy command, but so dynamically we need to use the stored procedures. Okay, so that you get handled and so next what we got, there is the file. So this is Okay, so then we have continuous data. For continuous data error handling, so task for schedule, we have grandparent child task. So they sometimes one or two times scenarios only they will ask, they're going to press like put force on this one. Go with task for scheduling. We are using types of loads, bulk data, incremental process. Okay, batch loading, how and streams explained. Okay, change data capture streams. Okay, stream table. Remember the three columns: metadata action, metadata update, metadata row ID. This is types such go with type 2. UDF use the different functions. So we have some average. The other by default we have functions, but UDF use a different function. As the requirement, we need to go and create the functions. So syntax you can see in the classes. Okay, store procedures like so readable code. Okay, if you want to do insert, delete, and update in multiple tables or in single table, then you go with procedure. And UDF and procedure, what language you going to use? So SQL, Scala, Java, JavaScript you going to use. Okay, even okay. So these are and RBS role with access control. Okay, this one like we have different types of roles like account admin, okay, data analyst, okay, public admin, user admin. Okay, so those are in real time. Accountant going to create a database set schema, or user admin going to create database set schemas, and we need to have the proper permissions. We want to work with any table. So if any employee goes to office, he need to access the data, right? So you need to have the proper access on the table directly. Can't access any database schema table. You need to have the select, or you can need to modify the data or delete the data. So delete means completely ownership you need. Okay, so like that, those RVs role based access control. Okay, accountable like that. So we explain and giants. So giants like left giant, right giant, okay, full giant, cross giant. So in one class I explained. Okay, go with take two tables and giants, see what is output on you are getting when you doing the left chain, right chain like that. And the masking policy. So when you go with like sharing data with okay PIP data, personal information like salary, employee, email, mobile number, to SSN, social security number for US people like Aadhaar card. So those we're going to hide and we're going to say. Suppose I have one table in that data I have like employee details, person details, and I also have the so employer details, employee and employer. Okay, so both details. We need to share data with both, but we going to create some secure views and we're going to share individually. So those they can't see entire data, so they can see only few data. And we have data sharing like so other person having a Snowflake account, how we going to share okay, data? We going to create a reader account. The other person don't have the Snowflake account, how you going to share? So third one, Snowflake Marketplace. Okay, three ways are there. So dynamic table is one table. Data modeling like star schema and Snowflake schema. So star schema is fact and dimension tables. Okay, data modeling. What is your using data modeling project means? So we go with star schema or Snowflake schema. Go with Snowflake schema. Okay, so star schema is for so uh, like is like denormalization or normalization. Denormalized data we have in the star schema. So Snowflake schema we have both dimension denormalization. Okay, so in schema in star schema we have one fact table and dimension tables surrounded by, and the Snowflake schema we have one fact table, dimension tables, and sub-dimension tables. So fact table having the numeric data. Okay, employee ID, so product ID, okay, order ID like that, patient ID, okay, doctor ID like that we have in the stars in the fact table. In the dimension table we have the description data. Okay, city name, okay, employee name, patient name like that. Okay, so the email ID, those description data. In the sub-dimension tables, we have like so region ID, date ID, those type of tables we have. Okay, so why we need to give the foreign key relationship when we are giving in fact table we have some all data, right? Okay, in dimension table we have every primary key we give. We going to be need to have the relationship with the fact table data. So every primary key need to be in the same in the fact table like that. Okay, remember fact table, numeric data, dimension, description data, and subdimension like region ID, date ID like that data. Okay, so here star scheme and denormalization, Snowflake scheme both normalization, denormalization. Okay, so denormalization nothing but okay when we receive data, so we don't have that so properly not it's going to store high data. So DRAM is having the duplicate data and everything. So but normalization don't have the duplicate data. Okay, it's going to have the repeated data. So in denormalization, we have repeated data, but in normalization, we don't have the repeated data. So they will ask what is the difference star schema, Snowflake schema, what is the normalization, denormalization difference between normalization and denormalization. So what is your approach? Okay, how you going to create tables for Snowflake schema? How you decide to fact and dimension tables? Okay. Okay, they will ask, and what is the OLTP and OLAP? OLTP and OLAP. So OLTP is a transaction purpose. Okay, if suppose you are working on a bank, so daily we go with we going to do transaction, right? Transactions every day we going to do for every day we going to do multiple transactions, 10 or more than 10, less than 10. Okay, we're going to do everyday transactions like it's going to have insert, delete, and update. Okay, so those will be done in the Oracle. Okay, SQL Server, those on-premises databases, but OLTP for completely so data analysis purpose. Okay, data analysis purpose. Okay, so example for OLTP, Oracle, OLAP is Snowflake, Redshift, the BigQuery. Those are the OLAP. Okay, cloud, completely cloud. Okay, these are. So they will ask what is the difference between. Okay, so both they will ask about this OLTP and OLAP. So then go with things. Okay, files. So for some study, I explained okay that warehouse vertical scaling and horizontal scaling, scale up, scale down, scale up, scale in, cluster key, micro partitions. Okay, so tell about those things. Okay, so that is performance tuning. Performance tuning. So if they ask about query, avoid star, James, okay, UCTE, okay, tell about project extender or staging a curated layer. So resource monitoring, like they don't ask you, but it is like so monitoring. What is the charges who run the queries, so what is taken charges, okay, what is compute cost and billing, it will go going to monitor by the so admin. So admin topic they don't ask you. So resource monitor, how you monitor, okay, not working, done by the admin, you can tell. So you no need to answer for every question. So you need to tell as a developer side. Okay. So billing, okay, admin side and the cache. So we have three types of cache. Okay, result cache. Okay, result cache. Okay, it's going to up to 20. Suppose you are running one query up to 24 hours. It's going to be layer and storing cloud services layer. Okay, which are going to store this result and going to store cloud services. Suppose I'm running one query, select star on table name where ID equal to 100. It's going to fetch the data. Second time, if you run the same query, it's not going to scan the table. It's going to fetch already. It's created one cache, right? From that, it's going to fetch the data. It's going to store in the cloud service. That is the metadata we have, right? So that one. So metadata cache is going to store in the cloud services layer. So suppose automatically it's going to refresh. So any changes in the table structure. So row count. Okay. So what is the maximum and what is the minimum values? It's going to show those types of data location partition. That is metadata capture. So and here we can call local disk cache or warehouse cache. It's going to store in the computer in the format of SSD. The compute layer SSD format going to store in SSD caches. Okay. So these are having like some storage and the storage cost. So whenever warehouse suspended, it's going to delete from the warehouse. Okay, cleared when warehouse suspend. Okay, so this is tell about these three types of caches, 24 hours. Okay, so result cache, generated cache, local disk cache. These are cloud services. Okay, these are 24 hours auto refresh and suspension free. So users credits local disk cache. Okay, so when new people have shared right notes. Okay, uh, so you have everything subset. Okay, everything. So I'm updating the syllabus. Okay, so something if you don't find that anything, okay, so that is not means not as you are work like as a developer. It will be some admin or other entries architect. Okay, so I'm making everything that's right. Okay, so have everything proper what you need. Okay, no worries. If you can't, if you find any folder empty like this. Okay, so you have this one and this one. Okay, that table types you have here. Okay, so this is how next. This is monitoring, cache, and page nation. This is a new concept. Okay, you need to use Python something different. Okay, not incredible as you now.
mean different concept, so new concept. But in future, I will update you. Okay, I will give you if you working with the developer. If you want to upgrade your skill, then you need to go with Page Nation. Okay, you can check the notes. Okay, so partner is simple. If you want to connect with any other tool, so you need to go with this one. Suppose you want to connect the DBT, you need a container username and password. This thing. So pricing. Okay, so example for one TB $23. Okay, like that. Okay, it will take care by the client only. Some it will going to monitor by the admin. Okay, so tagging is a different concept. Okay, new concept. Okay, you're not going to work on this monitoring pagination and tagging, okay, pricing, billing. So for just knowledge purpose I collected. Okay, so this tagging is nothing but suppose, so we are monitoring, right, warehouse. So we need to tag the warehouse database schema. We need to tag those things. Okay, so here you can see this is star schema. Okay, so fact and dimension. Okay, we have only numeric data here, and this is Snowflake schema, fact, dimensions, and subdimension, dim region, dim category. Okay, so go with. Okay, so what I'm explaining in this class, they going to ask only those questions. Okay, storage metrics, it going to you can see about details. What is the table occupying the storage and those things. It will you can see the storage. Okay, so what you going to work? You need to know about Snowflake theory, copy cloning, table types, standard, fail safe. So stages, data, consider data, copy command, error data, task, types of load, streams, SC types, UDF, procedures. So no need. We just have need to have chains, masking, sharing, dynamic tables. Okay, data modeling. Even you don't need. Okay, but you will have none. Performance tuning. Okay, they will expect nowadays they are asking about data modeling. So you need to. They are expecting these things. Okay, and okay, so performance tuning. Okay, monitoring, billing. Okay, do not need to know about these things. Catch it, okay, and partner conference like how to connect with the DBT you need to know. Okay, star schema. Okay, no need to know about these things. Okay, so this is complete. Okay, Snowflake. So then we go with DBT. So DBT nothing but okay. So here we have, so when we have the warehouse having the data, so after that we need to connect the DBT. Okay, how are you going to connect? Okay, so with the warehouse name, okay, database name, okay, and schema. Okay, you need to connect with the DBT and account identifier, username and password. Okay, so what you going to tell in the DBT, what you have worked on, models, test, metallization, and snapshot. That's enough. If you find anything in job description, so then you go with other things also. What you need that only, so model, test, metallization, snapshots. So what you need to know everything. Simply not. Okay, models are SQL statement only when we are receiving data when we have data in the Snowflake. Okay, we're going to connect. We're going to create some. Going to do some transformations. Okay, model. So DBT is ELT tool, extract load transformation. So when we have data in warehouse only, we can do it. Okay, we can connect and we can do the transformations models. Okay, so we have different type of models in the like so we can create a view and table. Okay, both. So test, what are the test types of test you have done? Unit test, Nathan test, accepted, values test. Okay, these are tests you have done. So DBT run, it going to run the all models. So when you run DBT run hyphen select model name, it going to run the single model. DBT run hyphen select model name 1 comma model name 2 comma model name 3. It going to run 3 model. So DBT run hyphen select folder name, it going to run all models in that folder. But in DBT run, it going to run like all models in from the entire DBT, all models. Okay, so that is the model how to run. DBT test, it going to run the so model again same thing repeat. Okay, all test, DBT test, run. So DBT test hyphen select. Okay, so test name we need to give. Okay, so metallization weave table incremental FML. So we know table we know incremental is for incremental data handling. Okay, so go with syntax, then you will get one idea. Okay, then other thing FML it won't create a viewer table. So for to save the cost only you will create. It won't create a viewer table in the Snowflake. Just we can check the data. So for so we can do so we can check the data with the FML. Okay. 4 types of materialization. And seeds like, so we can convert CS files like tables in the Snowflake. It is a permanent table. So this is only way to create permanent table in the Snowflake from the DBT. Okay. Seed, suppose you have CS file, you can paste, you can run DBT seed command. It's going to create a table in the Snowflake with the data. That is seeds. So that's why, okay, they are calling ELT2 DBT. Because of DBT, everybody used to say only for transformation, right? But it also extract and it also load. So with these seeds, it's going to extract and it's going to load into the warehouse. Okay. DBT you can connect with not only with Snowflake, with other things also you can connect. So this is seeds. Then cloud features that like Java schedule, those things. And Jinja, so these are some statements on SQL. We're going to use if else loop statements. We're going to write this stuff. So macro, so readable codes like Jinja templates only. So we can write formulas one place, okay, in macros folder. So wherever we need it, we can use it, those macros. And snapshots to access historical data. That is the type I'm going to implement with the snapshots. Okay. So hooks concept, when we run the model, what is happening the before and what is happening the after running the model, that is the hooks concept. So analysis folder, okay, it also not create any model ID viewer table in the Snowflake just for analyzing the data. So we can create and I can going to keep it in one folder. So but you're not going to use in real time this analysis folder. Just have it. Analysis for you are not going to create anything. And packages. Package is nothing but, so you are working in DBT. Suppose you are using DBT test 1 to 10. That column should be have only 1 to 10 numbers only. Suppose it should have like 1 to 100, but when you run the test it won't work. So that what you going to do, you need to go with the DBT. There is DBT utilities. You need to open DBT utilities website. There you can open the packages. There you can find these test files. Okay, that code you need to find, you need to copy and paste in the DBT. Then you need to use DBT deps command. You need to install those packages. Then you can use the you can run again the test 1 to 100 numbers accepted values test like that. So if there is, if you don't know anything, if you don't know the code how to write, if there is no package not working, then you need to go as a requirement. You need to go to DBT utilities. Then there you can see the code from that code. So you can use it and you can install in that DBT. Then those will be workable. Okay, so go with models, test materialization, snapshots, and they will ask like a DBT run. Okay, it will run the models, DBT test. The snapshot it's going to create a separate schema in the Snowflake. Remember, when you using snapshot, it's going to create separate schema. That is, you need to mention your target schema. You need to mention in the snapshot. It's going to create separate schema in the Snowflake. And okay, so you need to tell this one, and they will also DBT build. DBT build command you're going to use in real time. So when you use DBT build, it automatically going to run the like models, tests, snapshots, seeds, everything. That is command DBT build. So DBT build command going to run all models, snapshots, seeds, test. Okay, map everything is going to run. Okay, this is DBT. It is a DBT tool. Okay, so what I'm explaining in class, they're going to ask only these questions. So go with step by step. Okay, don't worry. Okay, and step by step, and you can CI/CD how you move data. Okay, how you do deployment using CI/CD, continuous integration and continuous deployment. And then they will test prod environments we have in layers in the DBT staging, interpret, mart layer. In mart layer we have fact and dimension tables data. Okay, so anybody having any doubts? So regarding, just go with these questions. You will get one idea. Okay, don't hurry, worry. Don't hurry, worry. Okay. So what I'm giving these questions, if you follow those questions and you will get complete real-time work. Okay, if you follow, so it's going to cover everything. Okay, so 1 second. Okay. So any doubt here? Jayaprakash, Koteshwaram, Renu, Rajesh, Shamant, Shekhar.
No, I don't have any doubts.
Yeah, Jaya.
said I don't have any doubts.
Okay. So here 1 second.
Sir,
So tell me, someone asking doubt.
yes, sir. Sir, by using DBT, we are loading data from one layer to another layer. Am I correct?
One.
One layer to other layer.
Yeah, environments. Okay, we have dev environment, test prod, right? So when we have data, we are doing development in dev environment, right? We are developing. So after that, you need to create those environments, test and prod. Then you need to give some setup there with again username and password, everything. Then you need to schedule the jobs. Okay, cloud jobs. Then so remember this pattern till to forget. Okay, with scheduling the jobs, it's going to move the data. If anything is error, we going to receive the email notification like that. We can run
Okay.
the.
So it is like moving data from one, like from dev to test to prod, like that.
Yeah, that
Okay,
is
okay.
CI/CD. Okay, we have every environment in the DB.
So when we are moving data from like raw layer to stage layer to that factor dimensional layer, that time we are not using DBT, right?
That when we create models, okay, where we select schema, right, it's going to reflect. So raw database, okay, I have raw schema. Then I connect with the DBT. So when I do the transformations and when I do the setup, it's going to if you give raw schema, it's going to only reflect in the raw schema. Suppose if I give a staging schema, it's going to create the stage schema. So usually we're going to create
Okay.
we need to give the stage schema. Yes, the requirement
Okay.
it would depends on the team how they are doing and what is their approach like that. Okay. Yeah.
Okay, sir.
So
Yeah, hi Madhu.
yeah.
Madhu, I have created a Snowflake account. So I just go through the recordings. So if you have any doubts, I will get back to you, Madhu.
Okay, sure. Just no worries, Koteshwara. So actually, the
Mhm.
batch is not properly. Some having some issues. I'm completed with interview
Mhm.
preparation. Okay. So while watching, if
Okay.
you have any doubt, you can ping me. Okay. When new batch
Mhm.
is confirmed, I will let you know. Okay. No worries. Okay. I will teach you again. Not I given regarding, but I will teach you. Okay. No worries.
Yeah,
Okay.
sure, Madhu. Yeah,
If you go listen next batch, so you will get more content every time. When I start new batch, I will give more content. Okay, more code
okay.
that will
Okay, Madhu. Yeah,
so you can find not only that recording videos, you can find more in the next batch. Okay, yeah, okay, fine. So
sure, Madhu.
yeah, okay. If you have any doubt, okay, you can ping me. Okay, okay,
Sure, Madhu. Sure.
okay. Yeah, thank you. So go with my YouTube channel. Okay, subscribe.
Yeah, sure.